This is a presentation on factoring completely by Mathematically Marcia. Okay, when factoring completely, we're going to check these 4 things. We're going to always start by looking for greatest common factors. Anytime we have 4 terms together, we'll try grouping. Anytime we have 3 terms, we'll try to factor the trinomial. And if we have 2 terms, we'll see if it's a difference of squares or sum or difference of cubes. Okay, remember, anytime we're factoring, we always start by looking for the GCF. And in this case, both of these are divisible by 2. And they both have an x, and they both have a y. So that would be our common factor, and we'll divide both of them. And also remember, anytime you're factoring, you are taking an expression or a number and you're breaking it down into parts. And you always factor it down into 2 parts. This one is broken down into 2xy, your common factor, and the result after dividing, which would be x to the 4th minus 16. Okay, now we want to see if there's more we can do. Can't do anything else to 2xy. X to the 4th minus 16, however, that is a difference of squares. X to the 4th and 16 are both perfect squares, and it's a difference. So there, the square root of x to the 4th is x squared. Square root of 16 is 4. So x squared plus 4, x squared minus 4. Notice we either keep it or we break it into 2 new factors. Okay, now check see if there's anything else you can do. 2xy still can't be factored anymore, so we bring it down. X squared plus 4 is a sum of squares. You can't factor a sum of squares, so we'll bring that down. X squared minus 4, however, is still a difference of squares. X squared and 4 are both perfect squares, and it's a difference. And the square root of x squared is x. Square root of 4 is 2. So x plus 2, x minus 2. Now x plus 2, x minus 2 are not perfect squares, are not difference of squares, so there's nothing else we can do. So this would be our factored form from 2x to the 5th y minus 32 xy. Okay, once again, let's start by looking for the GCF, which in this case would be 3. So the 2 factors we break it down into are 3, and then x to the 4th minus 13x squared plus 36. So now we know we can't break 3 down anymore. We do have a trinomial here. So let's do a times c, which would be 36. It's positive, so our signs are the same, and they're going to both be negative since b is negative. So negative 1 times negative 36. Negative 2 times negative 18. Negative 3 times negative 12. Negative 4 times negative 9. Negative 6 times negative 6. And this right here gives me negative 13. So that's the set we want. Now, we have x to the 4th there, not x squared. So we need x squared and x squared so that when we do the first, we get x to the 4th. And then it would be minus 4 and minus 9. Okay, now x squared minus 4 and x squared minus 9 are both difference of squares. So we'll bring this 3 down because we can't do anything with that. We can break this down. Again, remember, anytime you factor, you're breaking it down into 2 factors. Square root of x squared is x. Square root of 4 is 2. So x plus 2, x minus 2. And then this one, Square root of x squared is x. Square root of 9 is 3. So x plus 3 and x minus 3. And those are not difference of squares or cubes, or so this would be the factored form. Okay, on the next example, we will start again by looking to see if we have a GCF, or greatest common factor. And 2, 3, 50, 75, those do not have a common factor. And they don't all have a y, they don't all have an x, or they don't all have a z. So we do not have a common factor. So let's see what else we can do. We do have 4 terms, so let's see if we can group and make that work. Remember, negatives go in the parentheses, separate them with the plus sign because we're not multiplying these groups together. So let's write our groups out, leaving space for the common factor. So in this first group, they both have an x squared in common. So that gives you 2y plus 3z. And then over here, the next group, they have a negative 25 in common. Notice I divided by negative since they're both negative. And that leaves you with 2y plus 3z. So now 2y plus 3z is our common factor. So when we take that out, now my two factors that we break this down into are 2y plus 3z, and we're left with x squared minus 25. So now I have two binomials. So let's check to see if we can do anything with those. 2y plus 3z, you can't do anything with. It's not perfect cubes or perfect squares. X squared minus 25, those are both perfect squares, and it's a difference. So we can factor that. X plus a square root of 25 would be 5. So x plus 5 and x minus 5. And now we have binomials that are not cubes or squares, so we are finished. Okay, for this example here, we do not have a greatest common factor, but these are both perfect squares. Now when you take the square root of an exponent, you cut the exponent in half. So 6 divided by 2 would be 3. So x cubed, square root of 64 is 8. So x cubed plus 8 and x cubed minus 8. Okay, let's put our two formulas on here as a reminder for sum and difference of cubes. Alright, so our first group, and for both of these groups, the cubed root of x cubed is x, so a equals x, and the cubed root of 8 is 2. So b is 2. All that changes is the signs. So let's do this one over here, a plus b, so x plus 2, and then we have a squared, which is x squared, minus a times b plus b squared. And then for this one, we have a minus b, so x minus 2, and then x squared plus 2 times x plus 2 squared. Okay, that's the three factors. Now let's just go back and simplify these. X plus 2, and then x squared minus 2x plus 4, and then x minus 2, x squared plus 2x plus 4. And that's all you can do to these. Sometimes you can go back and put the binomials first, just because it looks better that way, but technically the order you list the factors is not important. This part would just be a preference here. That would be our factored form. Okay, let's start by looking for a common factor. The coefficients 1, 4, 8, 32 do not have anything in common. However, they do all have a y squared and they all have a z. So that would be my common factor. And when we factor that out, one of the factors is our common factor, y squared z. And then we're left with x to the 5th minus 4 x cubed plus 8x squared minus 32. So that's my second factor. Remember, we're always breaking into two factors. Now, the common factor usually can't be broken down anymore. But I do have 4 terms. So let's see if we can group this. Remember, when you group, plus sign goes between the groups. We're not multiplying them. So let's bring this common factor down so we don't forget about it, because it's still part of my answer. And then let's write these groups, leaving space for the common factor of each group. In this first group, I can take out an x cubed. And in this next group, we can take out an 8. So that leaves me with x cubed, x squared minus 4 plus 8, x squared minus 4. And of course we still have the y squared z. So your two factors here are x squared minus 4, that's the common, and when you take that out, you're going to have x cubed plus 8. So x squared minus 4 and x cubed plus 8. And of course we still have this y squared z. Now we can keep going. X squared minus 4 is a difference of squares, so let's bring this y squared z down. And x squared minus 4, square root of x squared is x, square root of 4 is 2, so x plus 2, x minus 2. And then x cubed plus 8 is a sum of cubes. Okay, and here is our formula for sum of cubes again. A cubed plus b cubed is a plus b, a squared minus ab plus b squared. And in this case, x cubed, cubed root is x, and the cubed root of 8 is 2. So a is x and b is 2. So the cubed root, so a, which is x, plus b, which is 2, and then x squared minus a, which is x, times b, which is 2, plus b, which is 2 squared. And so that gives us y squared z, x plus 2 squared, because there's 2 of them, x minus 2, and let's simplify this, x squared minus 2x plus 4. And these are my factors. Okay, we always check for a common factor first, and we do not have one in this case. Since this is 2 terms, check to see is it 2 perfect squares or cubes. And in this case, they're both perfect squares, and it is a difference, so we can do difference of cubes. When I do that, the square root of x to the 8th would be x to the 4th, square root of 256. Y to the 8th would be 16, y to the 4th. So we have x to the 4th plus 16 y to the 4th, and x to the 4th minus 16 y to the 4th. And let me fix these lines here. Those are our 2 factors. Now x to the 4th plus 16 y to the 4th, that is a sum of squares, which you can't do anything with. So we'll bring that down. This one, x to the 4th minus 16y to the 4th, those are still, that's a difference, and they are both perfect squares, so we can factor that more. Square root of x to the 4th would be x squared. Square root of 16, y to the 4th would be 4y squared. So x squared plus 4y squared, x squared minus 4y squared. And then we have another sum of squares, which we can't do anything with. Still, we'll bring that down. Here's another one we can't do anything with. We'll bring it down. Notice I either bring it down, leaving it exactly the same. Nothing changes, or we break it into 2 factors. This is a difference, x squared minus 4y squared. Square root of x squared is x. Square root of 4y squared is 2y. So x plus 2y, x minus 2y. Now x and 2y are not perfect squares. So now we have done everything we can do. Okay, once again, let's start by looking for the common factor. And all of these can be divided by 2, and they all have a y. So we'll pull out the 2y. So the 2 factors we break this into are 2y, and when we divide by that, our result is x to the 4th minus 8x squared plus 16. Okay, so our first factor, 2y, can't do anything more with, so we'll bring that down. Now, x to the 4th minus 8x squared plus 16 is a trinomial. Notice the first and last terms also happen to be perfect squares. So let's see if that's a perfect square trinomial. Square root of x to the 4th is x squared, so that would be a. And square root of 16 is 4, so that would be b. Let's see if 2ab is negative 8x squared. So, and actually we'll make that negative 4 since b is negative. So 2 times x squared times negative 4 does in fact equal negative 8x squared. So this would be x squared minus 4 times x squared minus 4. if it were our final answer, we would use an exponent of 2 instead of writing it twice. But those can be broken down more because they're perfect squares. Square root of x squared is x, or not perfect squares, difference of squares. Square root of 4 is 2, so x plus 2, x minus 2, x plus 2, and x minus 2. And 2y can't be broken down anymore. Now let's rewrite our final answer using exponents. We have x plus 2 2 times, and we have x minus 2 2 times. So that would be our factored form. If you liked this video, please hit the like button below to let me know. If you have questions, comments, or requests for future videos, please let me know in the comment section below. If there were parts of this video that you didn't understand, I do have other videos that explain each of the types of factoring into more depth. Please go back and watch those also. And if you'd like to see more videos like this, subscribe to my channel below. And thank you for watching.